Good evening, dear professors, teacher assistants. We want to present our final project. Our problem is from the travel company OneTwoTrip, which sells plane tickets. We needed to predict behavior of customers on the site, predict if the user will apply for refund. One of the challenges was that the data set contained anonymized features. This problem is important to solve because, as we found out, there are a lot of negative reviews on a ticket refund by this company, and proving this, actually a lot of customers return tickets due to various reasons will stimulate OneTwoTrip to make this option more convenient. Thus, it will increase the retention of customers.
After identifying the problem, the second step was loading the data. We have a dataset in the file OneTwoTrip challenge train CSV. It consists of almost 200,000 rows and 43 columns. Our target variable is a feature called by column goal1 that can take values either 1 or 0. We also set column order ID as our index. Our idea was to use an exploratory analysis of our data to make some meaningful features for our model. So we combined the third and the fourth step of the task. First, we performed visualization with Seaborn, and then, according to it, we've created 5 new meaningful features. At the beginning, we've checked our data for the presence of NaN values. There are no such values in the dataset, which is strange, since it is stated that the real data is used.
Let's move on to generating features. Our first feature is the ratio of adult tickets in one order. We looked at all columns and noticed that the values of several of them range from 1 to 18, field 15 and field 24. On the OneTwoTrip website, you can buy a maximum of 9 tickets, in both direction 18. So we assume that these columns show us the number of tickets for each order. Values of field 15 are equal or less than for field 24. Thus, we suppose that there are columns in our data that contain the values of other tickets. It turned out that the sum of fields 24, 28, and 9 is equal to field 15. So we can assume that the field 9 and field 28 show us privileged tickets or children tickets. It was decided to make a feature showing the ratio of adult tickets to the total number. We can see that there are no values equal to 0 because a child can't buy a ticket without an adult.
The second feature is the quantity of orders for each user in the dataset because we noticed that some of the user ID appears several times. We created a dictionary with all user IDs and their quantities and create a column. Using Seaborn count plot, we visualized this feature and it appeared that most users are not new to this company. The third and fourth features were created because of the interesting range 0 to 23 of values of field 11 and 23. This range made us think about hours. By plotting values of these two features, it appeared that field 11 most likely to be departure time because, as a matter of fact, there are less departures than arrivals at night. With the help of a new function time, we divided hours of departure and arrival into 4 groups that represents time of the day and visualized them.
The fifth feature was created because we have noticed that fields 2 and 3 take values from 1 to 12 that most likely to be months. As it can be seen that on the field 3 plot, bars of December and August are bigger than on the field 2 plot. These months are considered to be the most popular for flights. Thus, we can suggest that field 2 is the month of purchase and field 3 is the month of the departure. We found out that tickets can be bought no more than 1 year before the flight. So we calculated the difference between months, created a function that dealt with negative numbers, and applied it to the created column. We thought that there may be a field that shows the difference between the date of the purchase and the date of the flight in days. So we tried to find which field had the best correlation with the created column, and it appeared that field 16 has 0.92 correlation coefficient. Then we built a scatter plot, proved that to ourselves that it suits, got rid of an outlier, and created a new feature, full weeks between a day of the purchase and a day of the departure.
Our new features are ready, so we split our data frame into inputs and outputs. We dropped goal 1, goal 21, 22, 23, 24, and 25 from the train CSV file as leakage parameters. We assume that they are leakages because of the fact that they are not present in test CSV file. Then we chose our numerical features and categorical, and encoded it categorical by using one-hot encoder pre-processing from sklearn library. Next, we scaled numerical features by using min-max scaler. Scaling refers to the overall process of changing the ratio of a feature. This is a necessary step because features are measured in different units, which means they cover different ranges. It is best not to neglect this step when comparing several algorithms. I will scale by bringing each feature to the range from 0 to 1. Take all the values of the feature, select the minimum and divide it by the difference between the maximum and minimum. This way of scaling is often called normalization.
Then, where it was necessary to build a proper cross-validation procedure, we use it because cross-validation is primarily used in applied machine learning to estimate the skill of a machine learning model on unseen data. That is, to use a limited sample in order to estimate how the model is expected to perform in general when used to make predictions on data not used during the training of the model. It's a popular method because it's simple to understand and because it generally results in a less biased or less optimistic estimate of the model skill than other methods such as a simple trains test split.
For our model, we use LGBM classifier. LightGBM is a technique of a gradient-based one-side sampling to filter out the data observations. It is rather a popular classifier and it gives us better results than XGBoost and CADBoost. If we talk about parameters, we take quite a wide range of N estimators and nonleaves. Then we use grid search CV, and the idea of grid search is to run a model with a specific value of hyperparameter. So we set this parameter to some value, we run the model, we assess the performance of the model, and then we change the value of this hyperparameter, and again, we train the model, and again, we set the quality of this model with a different value of hyperparameter. And we do this many times as many values of these hyperparameters we want to check. Then we feed the model and choose the best parameters of this model.
So the best parameters of this model are N estimators 75 and nonleaves 5. We take these parameters and again put them to LGBM classifier and feed the model. As you can see, our data is imbalanced. The number of ticket refunds is much less. That's why we select an appropriate measure of quality, cross-val score with ROC-AUG scoring. Then we built ROC-AUG curve. It's a performance measurement for classification problems at various threshold settings. ROC is a probability curve and AUG represents degree of measure of separability. It tells how much model is capable of distinguishing between classes.
When we handle missing values, we obtain that there's no missing values. Then we generated up to 5 features: ratio of adult tickets, quantity of orders for each user IDs, time of the day for departure and arrival, full weeks between purchase and departure. After that, we built a cross-validation procedure with using key-fault model where a key is equal to 5.
For our model, we applied LightGBM classifier. We used ROC-AUG scoring because of the fact that we are dealing with imbalanced data, and using of LGBM classifier showed quite a high rate of the score for the model. Cross-val score equals to 0.68. ROC-AUG score of our model is equal to 0.7. So the goal of this task is accomplished, and our model evaluates the probability of ticket refund with a quite good score. So that's all we've got. Thank you for your attention.